Hello guys, in this video I'm going to explain you what is the gradient of a field. I'm going to give you the physical intuition of this. Gradient means direction of change. Gradient gives rate of change. Basically it's what gradient gives us, the rate of change of a scalar field. Like what do you mean by a field? Field could be a field of height. Like if you're changing your coordinate, by changing your coordinate you are increasing your height also. It is a field of height. If it is a electric field, by changing your coordinate, the magnitude of electric field is changing, that is electric field. And like that also there is temperature field, like changing your coordinate, temperature is changing, temperature field. So what does gradient tell us? Gradient tells us rate of change of that field, how it changes as we move along in one direction. That's what it tells. See, gradient is denoted by the symbol nabla. Here you can see nabla. And gradient has three components: one with x direction, another with y direction, another is with z direction. The del f upon del x is the partial derivative with respect to x. It is representing the rate of change of a function or a scalar field as the x changes, only x changes, and respectively del f upon del y and del f upon del z is representing how the field is changing if you are changing y or z respectively. Okay, so the physical intuition is simply like that. Like if you move along any axis, how the field is changing in its magnitude, that is what gradient is telling you. That's why it is simply partial derivative of field along that direction. That's why it is that. It is only telling you how the field is changing. And if you want a magnitude of gradient at one point, then this is the formula. You just take the square of respective gradients and just sum it up and take the root of it. And the sign of gradient also tells us the direction. If it is negative, then it will tell you that the slope in is the other direction. If it is positive, then you are moving towards the right direction. And gradient plays a very important role in physics. In machine learning, gradient is an optimization algorithm which is used in many machine learning algorithms to optimize the curve. Now I will take another example of gradient, the temperature gradient. See, imagine you are holding a cup of hot coffee and a glass of ice water in the other. Okay, so you can feel if the glass is more hot, like this will be wrong example. So I will take the example. Suppose you are holding a rod. Okay, it is extremely hot. Okay, but no, wait. I will take one very good example. Okay, wait for 1 second. See, I will. Here is the rod. Okay. Okay. So here is the cold section. Here is the hot section. Okay. Here temperature is like -30. Okay, -30, and here temperature is 40. Okay, and this distance is 5 meters. Okay, 5 meters. And here I will take the same rod, and here is temperature -30. Here -30. Here +40. Okay, but this distance is only 2 meters. So what does this information tells about the field of temperature field of this rod? Like here the gradient is more, here the gradient is more, and here the gradient is less. As we move along to the axis of rod, here the temperature is changing at a slow rate, and here the temperature is changing at a fast rate with respect to distance. That's what gradient is telling. So you can take this example. You can take this example of a rod as a perfect example for telling what the gradient is. And if it is changing at a high rate, then the magnitude of gradient along that direction will also be high. There are many examples of gradient. Weather patterns are also example of gradient, like how fast the weather is changing as we move along through the different regions. And I have told you the example of already heating metal rod. So the gradient is basically, if I sum it up, the rate of change of anything as we move along one axis, either say x, either say y, either say z. So that's all for the video. Thank you.